Hello. In this video, we'll be looking on example 4, sample question from the radioactive decay application, which is an application in differential equations, first order differential equations. So for this case, you're saying polonium-218 decays exponentially. I had explained how exponentially in my first video introducing this application. So the decay rate is 23.1%, which is this is our decay constant. Okay, decay constant, which in our previous video we have been labeling it K. So for this per minute, and can be modeled by this equation. Okay, so this equation has been used to model uh, the radioactive decay for this polonium 218. So our first question is, find the equation that satisfies this differential equation given these initial conditions. Okay, so these are initial conditions. So how will we do this? So our first step is to solve for this differential equation. So the differential equation is dp upon dt should equal negative 0.231p. Okay, so how do we solve for this? So let's separate the variables. So I'll take p to this other side. So it's dp upon p should give me negative 0.231 dt. Okay, if I take the integral of both sides, I'll say I'll get ln of p, okay, should give me negative 0.23 t multiplied by t. Why so? From this case, you're saying these are constant, take it outside the integral 0.231 multiplied by dt. So if I take the integral of dt, I should get t. Okay, then I'll multiply that by negative 0.231. Okay, that's the reason why we're getting this answer. So from this point, let's take the exponential for both sides. So we'll get p equal e raised to negative, and remember we should have a constant of integration at this point. So 0.231 t. Okay, this should be 1, not t. At this point, this should be 1 t plus c. Okay, but for this c, we have seen how we are solving for this. So remember, it's a multiplication of e again raised to c. So the e raised to c will go down to c, just a constant. So from this case, p equal e raised to negative 0.231 t. I'll multiply that by c. Okay, so once we have this, so this is our general solution. Okay, but the question asks, find the equation that satisfies this differential equation. Let p of 0 equal p. Okay, this is where these are initial conditions. So our first step is to solve for these initial conditions for us to get our particular condition. Okay, our particular solution. So we are saying where the original, the remaining amount p at a certain time 0. So let me indicate something at this point. So this is the remaining amount p at time equal 0. We should get the original amount. Okay, so from there we are saying the remaining amount p. Okay, so it's p as a function of time, should equal e raised to negative 0.231 at time equal 0. Okay, multiplied by c. From this case, we are saying this will go down to 1 because e raised to 0 is just 1. So I'll get p of, now the remaining amount, pt, of which pt we said equal p0. Remember, from this point, pt, p of 0, okay, p of t when the time is equal 0 is the initial amount p0. Okay, so this is just the same as p0 where time equals 0. We should get our answer as c. Okay, so from this point we are getting c equal p0. So if we write our particular solution, so I'll say our particular solution, of which it's our answer, we should say P of t, okay? P of t should equal C. Where there's a C, I'll replace that with P0 multiplied by e raised to negative 0.231 t. Okay, so that's our answer for that case. Then let's solve for the second question. It's saying if 1,000 grams of polonium is present when time equals 0, how much is present after 90 seconds? Okay, so for this case, this is our initial amount, which is P0. Okay, so taking our particular solution, P of t equal P0 multiplied by e raised to negative of 0.231 t. Okay, but what is 90 seconds? 90 seconds is simply 1.5 minutes. Okay, remember we are measuring in minutes. So we'll say how much is present. So P of t when time equal uh, 1.5. Okay, so let me indicate that when time equal 1.5 minutes. Okay, should give me the original amount 1,000 multiplied by e raised to negative 0.231 multiplied by 1.5. Okay, so this will, if we clean this a bit, we should get 1,000 multiplied by e raised to negative 0.3465. If we continue cleaning this, should get 1,000 multiplied by uh, e raised to this value is simply 0.77. Okay, 0.707. Okay, so if we clean that again, we should get our answer as 707 grams. So after a certain time of 90 seconds, we should get our P of t, the remaining amount, as 707 grams. Okay, so let's continue from that point. We are saying what's the half-life. Okay, so once we have this, we're having the particular solution, so we'll just copy the particular solution, which says P of t should give me my original amount multiplied by e raised to negative 0.231 t. Okay, so we need the half-life. Okay, so I'll say P of t a half should give me the original amount, which is 1,000 multiplied by e raised to negative 0.231 multiplied by t a half. Okay, so for us to solve for this, we are saying for half-life, when time for the half-life, this is the third condition. Remember, in our previous video, we're saying if we have a half-life, we are saying the 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 amount present after this time has elapsed. Okay, P of t should equal the original amount being halved. Okay, so from this point, I'll replace P of t as P 0 over 2. So from this point, I'm saying P of 0 divided by 2 should give me, this is just the original amount. I can label it P0 multiplied by e raised to negative 0.231 t half. Okay, from that point, I'll say a half equal e raised to negative 0.231 t a half. Okay, if I take the natural logarithm of both sides, I should get ln of 1 minus ln of 2 should give me the ln of e raised to negative 0.231 t a half. Okay, from there we are saying this will go down to 0, so I'll say negative ln of 2 should give me negative 0.231 t a half. Okay, so from there we are saying for me to solve for t a half, which is just my half-life, I'll say it's negative ln of 2 divided by 0, negative 0.231. If I solve for this, I should get negative 0.6931 divided by negative 0.231. Okay, so my half-life should give me about approximately, if you calculate this, 3 minutes. Okay, so please like, share, and subscribe to my channel and follow for more. Have a lovely day.